Hi friends, may I know who is in line? This is Sateesh Sir. Audio okay? Guys, please check your audio. Hi Bhavani, hi PTV Bhavani. Hello. Hi, hi. Yeah, see, in last video we discussed about reflection of light. Today we will discussing about we are planning to discuss. Good evening, good evening. We will discuss about a few things about refraction, like a plane surface. In next session, we may discuss about refraction to the spherical surface. Okay. So, what is the just I want to revise what the things we discussed in the previous class, in previous video. It is not a live session; it is a video recording session. So, reflection means the rebouncing of light into the same medium. Okay. So, there is no change in velocity in case of reflection, and we know that loss of reflection means angle of incident and angle of reflection both are same. And next one, incident ray, reflected ray, and a normal, all these three lies in the same plane. Okay. And after that we are discussed about what is the angle of deviation, and we learn the deviation formula. Deviation delta is equals to 180 minus 2i or 180 minus 2r. This is the brief discussion of what we done in the previous class. Bhavani, audio okay for you? May I know is that Surya is there? Surya, just you send, if you are there, you send one hi message. Audio okay? Odisha Botra. Okay, good evening. Good evening. PTV Bhavani and PTS sir. Audio okay. Thank you. Oh, Pandar Suryakala madam. Ma'am, you are bio teacher. Okay. Okay. So, what is refraction? What is the physical quantities will change when the refraction will happen? Refraction is a phenomenon. It is nothing but while the light ray travels from one medium to another medium, means either from air to another medium, air to water, or water to glass, or air to glass, means one medium to another medium. If the light ray travels from one medium to another medium, it suffers the bending, means because of the change in velocity of the light or the speed of light. Because of the change in speed of light, what happened, there is some change in path, means it is slightly bending from its original path, either it is towards the normal or away from the normal. I hope you understood what happened. If the light ray travels from one medium to another medium, what happened means because of the change in velocity of the light, there is some change in velocity. Because of the change in velocity, what happened, it is slightly deviate from its original path. Original path means suppose it is moving in a straight line, slightly bending, means depending upon the denser medium and optical medium, means it is moving from optically rarer to denser. Light ray initially it is in rarer medium. Suppose it is moving enter into the denser medium. Obviously, what happened means the speed of light decreases. Because of the speed of light decreases, what happened? It is slightly. Hello, Girubabu sir. Okay, it is slightly deviating from reasonable path. Slightly deviating from original path means what happens means rarer to denser. Speed decreases. Speed decreases means what happens? It is bending towards the normal. Suppose the same light ray, it moving from denser to rarer means now the light ray is moving from the denser medium to rarer medium, optically denser medium to rarer medium. Okay, what is reflection? Thank you. Giribabu sir, reflection means the phenomenon of the light rebounds into the same medium. Means the light ray travel from one medium to another medium. Between the two mediums, suppose we have an optical reflecting surface we have. If we have reflecting surface, the ray is incident on that. Again, it is rebounds into the same medium. That phenomena is called as reflection. That we discussed in the previous video. Today topic is refraction. Okay. Refraction we will learn now. Refraction is nothing but the bending of the light while it is traveling from one medium to another medium. I hope you understood. Means in case of refraction, means in the phenomena of refraction, what are the changing physical quantities means velocity will change, wavelength will change. Velocity will change and wavelength will change. Velocity and wavelength will change means frequency remains constant. Here, the frequency of the light remains constant. That is why, in case of refraction phenomena, the color of the light we will decide based on the frequency of the light. Why? Because we are taking only one color light, but it is traveling from one medium to another medium. Suppose if you take wavelength is the physical quantity to decide the color. What happens while it is moving from the rarer to denser? It velocity decreases. Velocity decreases means wavelength decreases. Wavelength decreases means what happened? Maybe the wavelength change means because of the wavelength we may think the color is different, but color of the light will not change. That is why in case of refraction, especially in refraction, we will decide the color based on the frequency of the light. Frequency is unchanged physical quantity in case of refraction. I hope it is clear. Okay. So refraction is the phenomenon, the bending of the light while it is traveling from one medium to another medium. What are the changing physical quantities? Only speed and wavelength will change. What is unchanged physical quantity means wavelength change, velocity change, unchanged frequency, frequency only unchanged physical quantity. See, this is the diagram I am drawing now. See, refraction means this is the boundary. This boundary is divide the medium into the total medium into the two surfaces, means upper one surface one medium, second one is second medium. Let us take this is rarer medium, this is denser medium, this is rarer medium, and this is denser medium. Okay, the light ray now I am taking, this is the source of light. From the source of light, a ray is incident on the boundary. This is the boundary which is separated the medium into the, okay, this is the boundary. Now, if you take here, the light ray now traveling from the rarer medium to denser medium. So what we discussed, light ray travel from rarer medium to denser medium. In rarer medium, the speed of light, if you take v1, in the denser medium, if you take the speed of light is v2. As we know that in rarer medium, the speed of light is more, means v1 is greater than v2. We discussed previously, I told you already, while light ray travel from rarer to denser means the speed of light will decreases. Means now, if you draw one normal here, this is the normal. This is the normal. So what happened means because of the decrement of the speed will decreases here. Okay. So the speed is decreases means it is slightly bending towards the normal. This is bending towards the normal. Giribabu, we will discuss Wibbeyer in case of dispersion concept. This is refraction. Okay, that is a different concept we will discuss. Okay. So now see this blue color light. This blue color light is indicate that is a normal. This is the incident ray. So the angle made by the incident ray with the normal is called as angle of incident I. Now, after bending of the light, it is make an angle some theta or some r that we taken as angle of refraction. Okay, this is angle of refraction. Angle of refraction. This is angle of incident. Okay, now what happened? The light ray here moving from the rarer medium to denser medium. Suppose if there is no boundary, means if it is a homogeneous medium, if the medium is homogeneous, what happened? This is the original path of the light. This is the original path of the light. But whenever the boundaries is there, this is the original path of the light. Here, because of this boundary means it is the medium differences, both are the two optical different optical mediums. What happened is slightly deviating from its original path. This is called as, here in this case it is called as angle of deviation. This is called as angle of deviation. Now the light ray moving from the rarer medium to denser medium, if you see that angle of incidence is always greater than angle of refraction. Angle of incident is always greater than angle of refraction. Now if you want to take this deviation, total angle, if you take this deviation, we can write angle I minus angle R. This is the formula when it is light ray travel from rarer to denser. If the light ray travel from rarer medium to denser medium, this is the deviation formula. Deviation we can write angle I minus angle R. Angle I is called as angle of incident. Angle R is called as angle of refraction. Okay, this is called as angle of fraction. Now here in last topic we learn laws of reflection. Similarly we have laws of refraction also. Here if you take, this is an incident, this is an incident ray, this is refracted ray, this is normal. These are all the fundamental points. Now second one, laws of reflection, important point is Snell's law. What is that? Snell's law. See, every medium having one refractive index. Refractive means optical medium. If you take every optical medium, one refractive index n1. This is n2. Okay, refractive index n1 and n2. What is the meaning of refractive index? Refractive index is nothing but absolute refractive index. What is the definition of absolute refractive index? Means it is purely the ratio between speed of light in vacuum to the speed of light in given medium. Suppose if you take the medium 1, refractive index n1. So this refractive index n1 we can write, it is a purely ratio of the speed of light in vacuum to speed of light in given medium. Speed of light, if you take here in the first medium v1, speed of light in vacuum is c. We can write c. Speed of light is c by speed of light in the first medium is v1. Similarly, we can write n2. Speed of light in vacuum is c and speed of light in the second medium is v2. So this is called as absolute refractive index of the given medium. Absolute refractive index of the given medium we can define as, it is purely the ratio between speed of light in vacuum to the speed of light in the given medium. So n1 we can write c by v1, n2 we can write c by v2. Okay, I hope it is clear. So this is the phenomena is happen when the light ray is moving from the rarer medium to denser medium. According to the principle of superposition, if you take, this is the source of light, the path followed by the light is this. Suppose if you take the source of light here, according to the principle of superposition, what happened? This becomes angle of incident, this is becomes angle of refraction. Means they will interchange. I becomes r becomes I. Then the deviation we can write angle r, my deviation what happened? This is angle I, this is angle r. If the light ray moving from the denser medium to rarer medium, now this on board, which what is the appear on the board is the case the light ray moving from the rarer medium to denser medium. Okay, in rarer medium to denser medium, what happened? Light ray is bending towards the normal, so we can write angle of deviation is anguli minus angular. Suppose if you take the source of light is in denser medium, means the light ray moving from the denser medium to rarer medium, denser medium to rarer medium. What happened means now this becomes angle of incident, this becomes angle of refraction. In that case, what happened means after the refraction, what happened means the light ray is bending away from the normal, means like this, bending away from the normal means in that case what happened means angle of refraction is more than that of angle of incident. I hope you understood. If the light ray travel from denser medium to rarer medium, means initially the source of light is in denser medium, we are sending the light rays from the denser medium to rarer medium, means the speed of light is increases. Speed of light increases means denser medium speed is less, rarer medium speed of light is more. So in such case what happen means the light ray after the refraction, what happened, it is bending away from the normal. In that case angle of refraction is more than that of angle of incident. In that case we can write, in second case deviation formula we can write angular minus anguli. Is it clear? I hope it is clear. This is the phenomena in first case. If you take in opposite way according to the principle of reversibility, we can write this is r minus I. If the light ray moving from the denser to rarer, we can write r minus I. Okay guys, you just copy that. Who is this Disha Botra? Hi Amolia. Hi Nimisha. All Mandaki batch is there. Hi Nimisha. Again online ray optics. Last time also ray optics online. This time also ray optics online only. Where is Suresh? Suresh. Suresh is not there. Ram Naidu sir. Okay. Now see. Absent. Who is absent? See. Snell's law we can write, say In case of refraction, what is unchanged physical quantity means frequency remains constant. That you should know. Frequency is constant. Okay. Wavelength and speed will change. Now see, we are apply the Snell's law. What is Snell's law means? The product of refractive index. What is Snell's law means? The product of refractive index and sine of angle. The product of refractive index and sine of angle of incident at a point in a given medium. Means according to the definition, see, if you take, this is point of incident, if you take O, the product of refractive index for the first medium, refractive index is n1 into sine of angle of incident. In first medium, angle of incident is this, so we can write sine I. According to the definition of Snell's law, this is the Snell's law. First medium, if you apply the Snell's law, the product of refractive index, sine of angle of incident at that point in the given medium. Okay, so that n1 into sine I is equals to constant. Similarly, if you apply Snell's law for the second medium, we can write n2 into, in this angle of incident, if you take principle of reversibility, this is r, we can take. This is sine r is constant. See, n1 into sin I, the product of n1 sin I is constant, the product of n2 sin r is constant. Now we can equating these two. n1 sin I is, can be, that we can write n2 into sin r. Okay, now from this we can write sin I by sin r. Sin I by sin r is equal n2 upon n1. This is the way we can write. This we called as Snell's law. So we are taking the phenomena here, light ray travel from rarer to denser. I am taking here rarer to denser. Okay, this we can write the refractive index n2 is equals to n2 by n1. Giribabu, I will explain after that. Okay, after this topic, I will explain what is Wigwire. Okay, please wait. I will explain. Okay, wait. Definitely, I will explain first. Let me complete this concept first. After that, we will go for that Wigwire concept. Okay, that is dispersion of light. That is a different topic. If you want, I will explain. No problem. Okay, see, this is Snell's law. The product of refractive index and sin I is equals to constant. In the second medium, n2 into sin r is equals to constant. We can write sin I by sin r is equals to n2 by n1. This is Snell's law. See. So this is the way we can write sin I by sin r can be written as n2 by n1. This is n21. So the way we can read this n21 is refractive index of medium 2 with respect to medium 1. This is the way we can read. n21 is nothing but refractive index of the second medium with respect to the otherwise we can write like this, mu21 also, mu or n, whatever it may be, you can write. It is sin I by sin r. This is the way. Okay, this is called as relative refractive index. n2 by n1 is called as relative refractive index. Relative refractive index means the refractive index of one medium with respect to the another medium. n21 is nothing but refractive index of the second medium with respect to the first medium, n21. Okay, so now see, absolute refractive index formula given. What is absolute refractive index? See, absolute refractive index is nothing but C by V. C by V means speed of light in vacuum by speed of light in given medium. Suppose if you take this is n1, it becomes v1. If you take this is n2, that we can write C by V2. So this is the way we can write. But in previous classes, either in 11th standard or 9th standard sound chapter, we learned the relation between speed, frequency, and wavelength. We have the relation V equals to F into lambda. Means velocity is directly proportional to the wavelength. So V equals to the product of frequency and wavelength. Okay. Now see, if you want to write this refractive index in terms of wavelength, so this we can write C by lambda 1, and this is C by lambda 2 we can write. Is it clear? So this N1 equals to, we can write C by V1, that equals to C by lambda 1. This N2 is equals to C by V2. So we know the relation between speed and wavelength. V equals to frequency into lambda. So this, instead of this V1, I am replaced with lambda 1. Okay. So this equation, see, suppose sometimes in ask, they will may ask in problems N2 by N1. N2 by N1 means here refractive index of the optical medium is inversely proportional to the speed of light. N2 by N1, we can write this is V1 by V2. And we know that velocity is, at speed is directly proportional to the wavelength. So this we can write lambda 1 by lambda 2. This is the way we can write. Now sin I by sin r equals to n2 by n1, that equals to v1 by v2, that equals to lambda 1 by lambda 2. Sometimes they may give wavelengths lambda 1 and lambda 2, they may ask what is the relative refractive index. Then we can write sin I by sin r is equals to lambda 1 by lambda 2. Sometimes they may give speeds, they may ask refractive index, relative refractive index. Then we can take speeds formula. Sometimes they will give refractive index, they may ask ratio of the angle of incident and angle of refraction. I hope it is clear. This is the way they may ask. This we can read refractive index of the second medium with respect of the first medium. This is refractive index of the second medium with respect to the first medium. After that, relative refractive, absolute refractive index formula, this n1 is equal to c by v1, that is equal to c by lambda 1. This is n2 equals to c by v2, that is equals to c by lambda 2. So this we can write, if they ask refractive index second medium with respect to first medium is equals to n2 by n1 equals to v1 by v2, that equals to lambda 1 by lambda 2. This is the way we can write the Snell's law. Okay. So just note down these points. This is important. Important means they may ask, there is a chance to ask the questions based on this. Hemalata madam, hi. How are you? So many days. How are you, ma'am? Hemalata ma'am? Guys, finished? This is Snell's law. So how they may ask questions based on this? They may ask problems based on this. See how to use this law. See, these are the different boundaries we have. These are the different boundaries we have like this. Okay. Now we have a source of light here. From here, the ray is incident like this. Let it may be medium 1. This is the first medium. This is the point of incident. So if you draw the one normal here, it may bending like this. It suffers refraction depending upon the refractive index. If it is a denser, bending towards the normal. If it is rarer, bending away from the normal. The second medium having refractive index N2, again it suffers here some refraction. This is one more normal. This is N3. Okay. So again it suffers refraction. You draw one more normal. Again subtraction. This refraction, it suffers refraction. Finally it will go like this. Okay. Now how many mediums we have? This is N4. Suppose this is the first medium and the last medium are the homogeneous medium. Means the first one and the last medium, N1 and this N5 are the equal mediums. It means homogeneous mediums. Means N2 is different, N3 is different, and N4 is different. But N1 and these two are equal mediums. Means both are having same refractive index. Okay, the speed of light is same in the both the mediums. Now they may ask here angle here or angle here or angle here or angle here. Now see, first case, this is angle of incident. If you take, this is I, here this is angle of refraction R. Based on the alternative angle concept, if it is R, what about this? This is also R. This you take I2, and here if you apply it, this is called as emergent ray. Okay. Now if you apply the Snell's law, N1 into sin I is equals to N2 into sin R. For first boundary, this is the boundary 1, I am applying Snell's law. N1 into sin I is equals to N2 into sin R. Okay. Similarly, if you apply the Snell's law here, N2 into sin R is equals to, if you take, this is I2, and this is also, it becomes I2. Okay. We can write like no problem. If it is a N2 into sin R is equals to N3 into sin I2, or R2 you can take, no problem. R2 or I2, whatever it may be, no problem. Some angle is there. And similarly, if you apply here, this is N3. For this boundary, if you take, this is I3, this is also I3. Okay. So N3 into sin I2 is equals to N4 into sin I3, and N4 into sin I3 is equals to N1. Again it will come to the N1. So this is equals to sine of angle of emergent. See, from the above 4 equations, see, N1 into sin I is equals to N2 into sin R. Here N2 into sin R is equals to N3 into sin I2. Means N1 sin I is equals to N3 sin I2. So from these 4 equations, we can write this is equals to this, and this is equals to this, and this is equals to this. Finally, we can write N1 into sin I is equals to N1 into sin A. Otherwise, if you take, this is the fourth medium, also no problem. If you take, this is the fourth medium, you write this is fourth medium, no problem. Okay. So N1 into sin I is equals to N4 into sin E. Okay. Means if both are homogeneous medium, if they given in problem, if they give angle of incident, if they ask what is angle of emergent, we can use this formula. N1 into sin I is equals to fourth medium into angle of emergent, we have to find out. Fourth medium refractive index into this. So if N1 is equals to N4, means both are having same refractive index, then this formula we can write, this is N into sin I, or N1 into sin I E is equals to n1 into sine A. Both refractive index get cancelled, so we will get angle of incident E is always equals to angle of emergent. So this is the way we can write angle of incident is equals to angle of emergent. Is it clear? We are apply the Snell's law here. Same here, here we are writing 4 equations with the different refractive indexes. Okay, so we are using the refractive index n1 sin y. So this is equals to this, and all we are equating. So we are getting this is equals to fourth one. So n1 sin I is equals to n4 into sin A. So if n1 and n4 both are having same equal refractive index, means if these two are homogeneous, means both are having same refractive index value, then we can write directly angle of incident is equals to angle of emergent. Okay, write this concept. See, we are apply the Snell's law here, right? Oh, Amalata ma'am, I'm doing well, sir. What about you? I'm fine, absolutely fine. Actually, I miss your contact number. I miss your contact number, and I'm not using Facebook also regularly right now. Sorry for I'm not giving reply for you also. I think on Teachers Day and my birthday also you're sending birthday wishes to me. And I think 4 days back I saw that Facebook. Girbabu. Sure. Sure, madam. Sure. Chandrasekhar Azad. Girbabu is last bench place. Last bench student. He never take the notes. Oh, Chandrasekhar sir will check your screenshots. Girbab sir, take proper screenshot. Danya. Hi, Danya. I hope all this you learn in 10th standard. Yes, yes, yes. Very good. Now, if you want to do personal charts, do personally. Okay, see, after this concept, we will learn about apparent depth. In Newton's laws of motion, 11th standard, you have apparent weight and apparent weight concept we have now. Sometimes it is moving upwards. If the lift is moving upwards, okay. If leaving or moving upwards means we feel that weight is more. If it is lift is moving downwards, we feel the lift. Our weight is means the weighing machine reading is less than that of the original weight. Similarly, the same concept we have apparent depth. Apparent depth means, see, maybe you don't know the physics, but you have the real time experience. What is apparent depth and a real depth means? Suppose if you take one glass of water, like if you went for any shopping mall or like some small shops, at the cash counter, if you see, if you observe that cash counter, one glass of water is there. Inside the glass of water, we have a lemon. They used to place one lemon. If you observe from the top of the glass, we feel that the lemon is slightly rising up. Actual, the position of the lemon is at the bottom of the glass, but we feel that there is no contact between the lemon and this glass. That phenomena is called as, we called as the real depth and apparent depth. So how to find out apparent depth and the real depth? See, means, how to find out real depth and apparent depth? Suppose if an object is in denser medium, means the lemon is inside the water, we are observing, means we are outside the water, means we are in air. So observer is in rarer medium, object is in denser medium. See, so the lower part is, if you are assume it is a denser medium, so we have an object here. This is an object, means just assume it is a lemon object. So this is incident rays. The ray is incident normally, means there is no refraction like this. Now this is one more ray is incident on this. What happened? Ray moving from the denser medium to rarer medium, means it is bending away from the normal. Here object is in denser medium, so the rays are moving from the denser medium to rarer medium. Means if you take, this is a ray, this, okay. Now if you do the observation, an observer is here. If he done the observation from here, for him it appears like this. For him, the observer who is outside the water, here, for him it is appears the object is here, means the real position of the object is here at the bottom, but he feel that the object is here. So this is called as, from here to here, this is called as real depth. From here to here is called as apparent depth. See, once again I repeat, suppose if you take the surface from here to here, this blue color line is indicates that real depth, so real position of an object, okay. But according to this person, the image is formed here. This is I. Now see, this red color line I show here. See, from here to here, this red color line is indicates that it is apparent depth. AD means apparent depth. This is real. So now I am giving the points. If you take this is O, and you take this is point A, this is point A, this is point B. Now we have a triangle here. Triangle, you take this is O. OAB is one triangle and IAB is one triangle. From where apply the Snell's law here. See, this is the real depth, this is the apparent depth, and we are writing the angles also. If you take this is I, and this is becomes R, and this is becomes I. So this is the way we are calculating apparent depth and real depth. So from this diagram, we are writing, say, here if it is I, this is angle I, this is angular. From the triangle, this is, we can write sin I is equals to, what is the formula of sin I? Sin I is equals to opposite side by this, that AB by sin. For the small angles, we know that tan I can be written as equals to sin I. So tan I formula, opposite side by adjacent side. For this I, opposite side is this, and this is adjacent side. We can write AB by AI. AB by AI. Similarly, tan R we can write, tan R is equals to sin R, that we can write. For this also, opposite side is AB. This is opposite side. For this R, opposite side is AB. And adjacent side, if you take this is OA, or OA we can write, or AO. Okay, you take this is first equation, this is second equation. Guys, you see we have two triangles, triangle AIB and OAB. Two triangles is there. From the triangle, sin I value and sin R value we are calculating. Now we are calculating the, apply the Snell's law. Snell's law formula, mu is equals to mu2 by mu1 is equals to sin I by sin R. If you take the ratio between angle sin I by sin R, if you take sin I by sin R, sin I value how much here? AB by AI. Sin R value how much? This sin R is equals to AB by AO. Okay, this AB get cancelled. Finally, we got here AO by AI. So I'm writing here, say, sin I by sin R is equals to AO by AI. So AO means the distance between these 2 points, extreme points. AO is nothing but real depth. That is called as real depth. RD means real depth. AI is nothing but apparent depth. Okay. So we have the formula. This is relative refractive index. Sin I by sin R is equals to relative refractive index. So real depth, so we can write relative refractive index mu relative is equals to real depth by apparent depth. Okay. Now see, in this case, we are taken that object is in denser medium, observer in rarer medium. Actual distance, suppose if you take from here to here, it's 10 centimeters, but for observer it is appears less than 10 centimeters. Means whenever the observer is in rarer medium, if the observer is in rarer medium, means observer is in air, object is in denser medium, for him the apparent distance is always less than, means in this case apparent distance is always greater than real distance. Apparent distance is always less than real distance. Suppose if you take this is 10 centimeters, now the object is appears here, it is less than 10 centimeters. Example, how they will ask in examinations means, suppose one fish is there, fish is in water, in air, fish is in sky or in water, water. So here we have a fish, here we have a bird, bird is an observer. So what is the distance of the fish from the bird? If they ask means, if they give the depth of the sea, at the depth of the river, if they given 10 centimeters or 20 centimeters, For the bird, it is always appears is less than centimeters, less than 10 centimeters. I hope you understood. For the bird, the fish is appears always less than that of the original distance. If the original distance is 10 meters, for the bird it appears less than 10 meters, means it may be 9.5, depending upon the relative refractive index value. So if you want this relative refractive index, what is relative refractive index means, how to write relative refractive index means, relative refractive index means a refractive index of the object by relative refractive index of the observer. This mu r we can write object. Where is the object? Here in denser medium. Denser medium refractive index by rarer medium relative refractive index. I hope it is clear. See how to write this relative refractive index means refractive index of the object. Where is the object? That object refractive index. If the object is in one medium, that medium refractive index by where is the observer? That observer refractive index. Okay, so this is the formula to find out real relative refractive index is equals to real distance by apparent distance. If the object is all denser medium, observer is in rarer medium. If the object is in denser medium, observer is in rarer medium, then what happened? The apparent distance is always less than that of the real distance. I hope it is clear. If the object is in denser medium, observer is in rarer medium. Observer doing the observation from the rarer medium means apparent distance is always less than that of the original distance. So we have to check the options. Suppose real distance is given 10 centimeters. In competitive examinations, how to solve this kind of problems? If the real distance means the depth of the other height of the aquarium, they give 10 centimeters. If they ask apparent distance, we have to check the options. How many options with less than 10 centimeters? By God grace, only 1 centimeter is there. Only one option less than 10 centimeters is there. That is the answer. I hope it is clear. Is it clear? Copy this. Okay. Now in opposite way, if the object is in rarer medium, means now fish is observing the bird. Fish want to see the bird. In such a case, what happen means, suppose object is in denser medium, we know that real apparent distance is equals less than that of the real distance. Suppose if it is opposite way, opposite sense, then apparent distance is always greater than that of the real distance. See, observe that difference between these two concepts. Say if the object is in rarer medium, now object is in upper, means in denser in rarer medium, observer means fish is here observer, object is bird, fish is observing the bird. In such a case, this apparent distance becomes ulta, means apparent distance is always greater than that of the real distance. Is it clear? Use the same formula. Relative refractive index is equals to real distance upon apparent distance. But while you calculating the apparent distance value, If the observer is in denser medium, we will get what is the original height. Suppose original height of the board is 10 centimeters. Answer 100% it is more than 100 centimeter. 10 centimeters, not 100 centimeters, 10 centimeters. Suppose they given 1 meter height, answer should be greater than 1 meter. If they give height 2 meters, the answer should be greater than 2 meters. Okay, is it clear? We have to check the options. How many options with more than 1 meter? Suppose we have only one option, no need to solve the problem, directly go for that option. Is it clear, guys? Okay, is it clear? This is the way we are doing the problems based on the real depth and apparent depth. Whatever the things we done in this case, exactly opposite sense we will get in case of another way. I hope it is clear. We will meet in the next session. Have a nice day. Thank you. Thank you very much. Bye. See you.